Is he there?
Yes, good afternoon.
Yes, he is. So I'll introduce you. So the next presentation is utilizing artificial intelligence for advancing LENR, mining and mastering LENR literature. Anasse Bari from New York University, USA.
Thank you very much.
You can proceed.
Thank you. Good morning, everyone, or good afternoon, everyone. Greetings from New York, and thank you for being here for this talk. My name is Anasse Bari. I'm a professor of computer science at the Courant Institute of Mathematical Sciences. I also lead the Predictive Analytics and AI Research Lab. I'm very pleased and honored to speak to a group of scientists like you about the AI and LENR work that I've been co-leading with Professor David Nagel of the George Washington University. We started this work in summer of 2023. It's been almost a year, and we have a first snapshot of what we have achieved together under the sponsorship of the Anthropocene Institute. So the outline of the talk is as follows. We will, of course, highlight briefly features and implications of LENR that I'm sure that many of you are already familiar with. And then we will talk about the need for using AI for LENR research. And we have, together with Professor Nagel, we've set up with a team two main objectives for the New York University AI for LENR program that we will share with you. And then we will talk about the components of the AI LENR research program in terms of tools, algorithms, and deployed frameworks, as well as what were the impacts that we've had so far of this program. And then we'll discuss a summary and prospects, and we'll open it for questions. I'm sure that we all know the promises of LENR. There is a lot of desirable features, as you can see: low cost energy, safety, good for climate change. There's a lot of potential there, and we also must know that there's a lot of scientific and engineering challenges that must be overcome, obviously, to realize the potential of LENR. And we think that there is an urgent need for using AI for LENR research for many reasons. The first one is there is an extensive LENR research literature that it's unstructured, and it's not just too big for individuals to analyze, but it's also not structured to be used by machine learning and artificial intelligence. We have about 5,000 reports, publications, and presentations that are all over the internet. And on the other side, there is a lot of new and mature AI capabilities that can significantly benefit the LENR community to advance the field and support the research as well as the commercialization of LENR. So the two main objectives of our research program are: one, we want to apply existing AI algorithms to structure and analyze the rich existing literature of LENR for the purpose of extracting insights and forward insights that are not easily obtained without using analytics and AI. And objective number two is to design and deploy AI tools to support the acceleration of the research that we're and you are all doing on LENR, as well as the commercialization of LENR. So far we have developed about 4 to 5 tools and components for the program. The first one is the data hub, or a data lake for LENR literature. The second one is a dashboard that has descriptive analytics of the data that we've collected from creating this data lake. And then number 3 is a LENR machine learning similarity tool that looks at supervised learning, supervised machine learning to find similar publications from the LENR literature. And the fourth one is we released recently an initial version that it's still under test for a large language model based chatbot. And we're about to release a search engine that relies on not just keyword-based search, but also semantic search from large corpus of LENR. So I'll be going quickly over these four components, and I'm happy to take questions at the end about each and every one of them. So for the the problem that we encountered at the beginning when we started collaborating with Professor Nagel is that we realized we need to put all the publications and LENR data into one place as a data hub or a data lake. There's a lot of publications, as we know, over 30 years of LENR experimental reports. The data is unstructured. There's a lot of PDFs, a lot of PowerPoints, videos, several formats, scanned documents, and the information is scattered all over the internet. And so basically what we did is we spent a lot of time collecting automatically as well as manually a lot of the LENR publicly available publications, and we had to structure them so that they can basically be fed to machine learning. And we now have a very large LENR corpus, what we call as a centralized storage that has everything in one place. And this is just a snapshot on some of the data. We relied, our starting point was Jed Rothwell's very well organized literature, but then we added a lot of things in terms of other documents, which we reached now about plus 5,000, I believe, documents, and some of them are very lengthy in terms of the pages and the content that they have. So that led us to present the data, and we have a first preliminary version of a dashboard that basically just pulls from the data hub to present publications per year, the authors, relationships. We also have a component where we applied machine learning to cluster similar documents based on the topics that were automatically extracted by AI algorithms. And this could be somehow very useful to researchers in LENR. We've done this for other fields, and we believe that this could be also used for scientists within the LENR community. We also went and applied some graph theory to represent the authors in terms of co-authorship relationships over the years, as well as a lot of things with regards to the publications and the topics. And the dashboard is publicly available. Now, the third component is a publication similarity tool. The problem that we try to address here is that there is a lot of similar reports across the years, and they could be similar based on semantics, based on graphics, based on keywords, based on topics. And we did our first attempt to develop a supervised machine learning framework that encapsulates a lot of algorithms that basically works as if you want to know the top 5 or K most similar documents or reports of a given LENR publication, this tool is able to some degree to provide you with that information. And as you can see, the way it works is as simple as uploading the documents, and then it returns with a K as an input, the number of documents that could be similar, that are similar to this one. And of course, there's a lot of algorithmic design that went behind this tool, and we're still tuning it, but we have the first version already out there, where you take the document, you go through a whole AI process of restructuring the document into vectors and applying a lot of linear algebra, then dimensionality reduction and clustering and tokenization before we get into topic representation. The fourth component is an LLM-based LENR bot. The purpose behind this was to provide the community with a kind of like an LENR GPT that will help in scientific research. And one of the main problems that we were trying to avoid by building our own on our proprietary data is to avoid the problem of hallucination. And in this case, what we're trying to see is that in case, instead of going to a large language model that has access to a lot of noise, it could basically not be able to give you very relevant answers, but it might hallucinate. So we released the first version. It had about three 3,700 plus LENR publicly available publications. And it took a lot of work to basically organize the data for the algorithms in terms of conversions from PDF to XML and then other format that are machine learning friendly. And we're still on the testing phase on this. We did some initial testing. It looks like the precision and recall were okay, but we're still doing a lot of testing and tuning. And it works as basically as exactly as ChatGPT, where you ask questions, you can ask follow-up questions. They can provide you with the links of the publication if it's already indexed within the knowledge base of the LENR chatbot. So what are some of the impacts that we aim and we are in process of having with this project is one, scientists that are working on LENR now can use these tools and can try them, and we're constantly doing the updates. Of course, writers that are wanting to learn about these the LENR, they can easily go there. We have students here at New York University in physics majors and computer science major that are interested in this field, and they're using these tools to get into the field as newcomers. And of course, we're also looking into extending the research more with looking into not just the text-based data, but also looking at experimental data. So this is one of the prospects that we're looking at involving AI to data from LENR experiments. And the team here, Professor Nagel and I, are inviting you to collaborate with us to do more research around LENR experiments data. And this is mainly done at the Courant Institute within NYU, and it's supported by the Anthropocene Institute, and it's an ongoing research project. The semantic search is almost deployed, and we hope to release it sometimes this year. And we had two publications that are publicly available for anyone who wants to learn more about our work. One was published just, I believe, last month or actually this month at Frontiers Artificial Intelligence, and the other one was presented at the ICBDA, the Conference on Big Data Analytics in Japan. And on behalf of the team, I'd like to thank you, and I'm happy to take questions. Thank you very much.
This is a really interesting project. I think we all look forward to being able to do a semantic search, like a ChatGPT search against the database. So does anyone have any questions? I assume.
Yes, I have questions.
Okay.
Already I'm having microphone here.
Demeter, why don't you go first?
Okay. My question to you is, let's say that there is some kind of initial established technology, or at least based on the experiments, successful experiments, which supposed to be transferred into the technology initially. How do you see the application of the artificial intelligence in this case?
So if I'm understanding correctly, you're having data from experiments.
Yes.
And that experiment is about to become a commercially available technology. And the question is how AI could help.
Yes.
Well, I mean,
exactly.
One of the things, yes. Well, one of the things that we're actually looking for is to get a lot of data on the experiments. I mean, there is a vast variety of mature AI technologies such as predictive analytics and semi-supervised learning and others that could look into, for instance, we can analyze the risks of the deployment of this technology. We could also look into making predictions on insights. I mean, it's hard for me to tell you exactly what could be done if I don't have the data in front of me that I could see it. But I think there is a lot of things that we could do, including assessing risk. We could do simulations and see forward insights into predicting what could happen next. If there are similar experiments in other domains, we could feed that into the AI to see what insights we could get by comparing what you are proposing and the others. So I'm happy to follow up on this. If you have some data or experimental data, we're happy to look into it, and we can provide you with a plan on how AI could help.
Okay, are we going to feel comfortable if my PhD student working in this field will contact you?
Of course, yes.
Okay, thank you.
Definitely. And Professor
Thank you.
Nagel should be in the
thanks.
conference. He can give you our contact. We're happy to help, yes.
Okay, go ahead.
Hi, Rob Kimball, Solitic. This looks incredible, very interesting. How do I get access to your data lake?
We have it on the dashboard. If you want the actual data, we're happy to send it to you as well. If you want it structured, we're happy to send it to you.
I think I've been on your, the part of the
Yes.
site that has the author network.
Yes.
Is that got access to the entire data lake?
The last update I think we did was about 3 months ago, and we're doing another update, but it has access to the publicly available ones. So we wanted to keep things within the norms where we have the publicly available ones. We have some data that has more than the papers that we see on the dashboard, and we're doing an update by the end of this month.
Rob, I will put you in touch with Anasse. Dave Nagel here. I'll put you in touch with Anasse to follow up on what you're saying.
Okay, thanks.
Next is Tom Grimshaw with a question.
My question is the result of readily confessed ignorance in AI processing. Years ago, my education was in geology, and years ago we had new database management systems coming out. This was back in the 1970s or so, and we had a young, we were hearing about all these virtues of this database. We had a young professor stand up and said, "Okay, can this tell me which ones of the papers are good papers?" Okay, and of course that brought down the house. Everybody thought that was pretty funny, but it does lead to the question: how does AI or how do you deal with the quality of the papers? I mean, not all papers are created equal, and there are some really good ones and some that are really awful. So how do you deal with that?
Thank you. That's a very, very good point. I don't think we have this in place yet, but we can definitely look into it when we get into the release in the semantic search. One of the things that comes to mind is when we convert a paper into a vector in terms of the words and the topics, we can add other features to that paper, including the number of citations, the number of mentions. We can add more metadata about the co-authors and other things, and we can add a ranking mechanism that will include these into the papers. And we might need your help and all the scientists. I'm not an LENR expert, to help us come up with these features or indicators that we can add as we index every paper, and probably that could help to say, let's re-rank these papers based on this specific criteria, the goodness of the paper.
Well, I'd like to let's thank Dr. Bari for a very nice presentation, and also Dr. Bari and Dave Nagel for organizing this project, and to the NYU LENR AI team, because this could become a really useful resource for the field as time goes forward.
Yes, thank you very much. Thank you. Thank you. Thank you.
Oh, we do have an online question. So,
Sure.
Can you see that question? Can you see that question, Dr. Bari?
The question is, how did the team handle OCR errors and data cleaning generally?
Yes, that's a very good question. We had to sit down and do it manually. That's one of the things that AI couldn't 100% do, and that's why it took us a little bit of time to come up with a clean data. Every time we had OCR problems, we had to just go back to those documents and basically break them down manually.
Thank you.
Thank you.
We have more if we have time.
Is there another question online, or?
Yes, no, it's here.
Oh, one more question in person here.
Yeah,
if you don't
sorry.
mi- if you don't mind.
This question made me come to mind another question. Maybe I missed because I was out for a part of the presentation, but how do you deal, and could that be a big improvement if it's not dealt with the translation? I mean, there's plenty of Russian papers on the subject. And you know, Italian, Japanese, things which are published only in national publication and things like that. Is this dealt with in some way?
Thank you very much. That's a very good point. It's on our list. I think Professor Nagel brought up this point when we were first doing this, and we are planning to include it in the next versions. But you're absolutely right. We have a lot of publications that are in different languages, and we just haven't included them yet.